Hello, viewers and dear students. Welcome to everybody in my new channels. Today we are discuss about the topic of complex number. We have already discussed in the previous video of the lecture number 1 from the first year class book. Now we proceeding for this topic. Some points are discussing here. Complex and complex number. The first point f and the number of term is an even number. So iota की power n is equal to plus minus 1, we get the answer. This is the general condition if we are using for any even numbers. For example, if we substitute or put n is equal to 2, then iota square is equal to minus 1. So we already discussed already in the previous unit. We can derive taking square on both the square root. So this will be cancelled to each other. So iota is equal to minus 1 under root. Already discussed in the previous radio of my complex number. So now if we, for example, if we put n is equal to 1000. How we can derivation of this one? Iota की power 1000. So we can write iota की power square whole की power 500. So iota is equal to minus 1. So the power is odd number. So we get the odd number. Similarly, if we put another condition we are using here now, if n is an odd number, so iota की power n is equal to plus minus iota. Look here, if we put, for example, if we put n is equal to 3, so iota की power 3 we can write iota square into iota. So the square is equal to minus 1 into iota is equal to minus iota. Similarly, if we put n is equal to 99, so how we can write iota की power 99? We can write, for example, for the student this will be simplification is difficult. We can divide by 2 this one. 4 multiply by we get 8. 1 is remaining. 9 is total 19. Now 2 9s are 18. We get 1. This will be remainder. Now the simplification by the iota term we can write iota square exponent 49. This will be changed into 49. Remainder is dot into multiplication because the power of the exponent is 1, so we can multiply by 1. Now the simplification of iota square into 49 into iota. Now minus 1 whole power exponent 49 into iota. So this is odd number, we get automatically minus iota. Now we are proceeding for the conjugate of complex number. Is conjugate of complex number and conjugate of complex number. So the real part is same. There will be no change, or we can say there no effect on real number, but an effect of imaginary sign. So conjugate of a complex number Conjugate a complex number, so the imaginary part, the sign of imaginary part always be changed. For example, let Z be any complex number in the form of A or B. That is, we can write Z is equal to A or B. This is order form. We can change also A plus iota B. Now, if we take the conjugate symbol, how we can represent? It is represented by Z bar. Z bar A plus iota B. So it means that here we change the imaginary part, so there will be no effect on the real part. So the sign will be changed into negative. Similarly, for example, we take one of the example. Z is equal to minus 3 plus 8 iota. So if we take the Z conjugate, so the sign of imaginary part will be changed. Look here, here is the sign of real part is also negative, so this will be no effect on this. But this sign of imaginary part is affected, so we write minus 3 minus 8 iota. This is the conjugate of complex number. It means that at conjugate or complex number, we always change the imaginary part of sign, but there is no effect on the real part. Now we are proceeding another form of absolute or modulus of a complex number, and how we can prove it of the formula of modulus complex number. Absolute of a complex number, or we can say that modulus of a number. Let's similarly we take let Z be any complex number, in the form of A plus iota B. So Z is equal to A plus iota B. So we take the absolute is represented by two straight lines. That is represented by our modulus, we can say there. But here we cannot say magnitude. Magnitude are used in the vector chapter we have already discussed in the next video, inshallah. So here we take a square plus b square under root is equal to a square plus b square. So this is called modulus or absolute of a complex number. Now how we can derive the proof of this one? Look here, we are taking, for example, in the xy coordinates plane, y and y dash, there is one point, for example, M lies on the x-axis, so it is represented by A. Similarly, O, Y lie and B. And there is one point lies in the first quadrant, this first quadrant A or B. It means that on the x-axis lie A point and the y-axis and the B point. So this line is parallel to this line. So we join this one, and this hypotenuse is represented by Z, or we can say that R. So let we want to prove that formula of the above absolute. Let OM is equal to A and MP is equal to B, because this line is parallel, Y is parallel, so this line is also B. Similarly, and OP is equal to R equal to Z. Now we want to and triangle, taking triangle OMP. So according to the Pythagoras theorem, we can write hypotenuse ka whole square is equal to बेस का होल स्क्वायर plus perpendicular whole square. This is the notation for perpendicular. Perpendicular notation we are used perpendicular. Now here hypotenuse is we get already OP. This will be hypotenuse. This is called base, and this will be represent perpendicular, and this will be represented by hypotenuse. Hypotenuse is equal to OP whole square, and this will be base. Base is equal to A square, means that OM we can write OM whole square plus and perpendicular MP whole square. OP is here Z square is equal to OM is equal to A square plus B square. Now taking square root on both sides of the equation, so Z absolute is equal to A square plus B square. This is the required proof of the absolute or complex number. Thank you very much once again. So the next video according to the topic will be coming shortly. Thank you very much once again.